So air standard cycle, it is very important. Huh? In next 2 semesters, you have to understand this air standard cycle, then you will understand everything in the coming semesters. So cycle, we already know what is a cycle. Cycle is a successive processes which bring the system to the original state. So a cycle basically repeats same thing again and again, and as a result we get some work output from that cycle. And this, whenever we say air standard cycle, actually our intention is to analyze the heat engine. But in heat engine, it may be petrol engine, diesel engine, whatever it may be, we take some theoretical cycles which we call air standard cycle, which is applicable in different engines, maybe petrol engine, diesel engine, different cycles are used. And this, during the analysis of this cycle in a heat engine, this air is assumed to be the, so in air standard cycle, the working fluid is assumed to be air, working fluid. But in heat engine, it may be different. It may be air fuel mixer, gas, and it keeps on changing. At the entry it is air, at the exit it is gas. It is difficult to analyze in that situation, so we assume that the working fluid is air, atmospheric air. So the properties of the air will remain same throughout the cycle or throughout the different processes. So in air standard cycle, there are some assumptions. That we will discuss in the next slide. But first assumptions, I have already mentioned. What is the assumptions? Air is the working fluid. Working fluid ki hoy? Working fluid to ki kolu ami? Fluid is air. And the properties of specific heat properties, that means Cp, Cv, these properties remain same throughout the cycle. This is another assumption. And the process is frictionless. So what is a frictionless process? So it will lead us to reversible process. All the processes involved in the cycle are reversible. That means we can say frictionless processes. Other assumptions I will discuss in the next slide. Okay. Suppose today we will discuss one cycle which is called constant volume cycle. Constant volume cycle, which is also called Otto cycle, after the name of the scientist or engineer who discovered this cycle. Okay. Constant volume cycle, or we will call it Otto cycle, O-T-T-O, Otto cycle. So a cycle will definitely have some processes. Suppose this is the PV diagram for the cycle. PV diagram, and the processes are 1, 2, 2, 3, 3, 4, and 4, 1. These are the processes for Otto cycle. Now suppose from the diagram, PV diagram, you can easily say what process 1, 2, what is this process? Whatever you know from the diagram, PV diagram, what is this process? Volume increase compression process. Excellent. So process 1, 2 is compression process, and I want to add with you that this is PV to the power gamma equal to C. So what does it mean? Compression, you know, you have already mentioned this is a compression process, and I also write for this process PV to the power gamma equal to C. So what is this? Adiabatic compression. In the assumptions we said that all the processes are frictionless, so that means reversible. So if the adiabatic processes a process is reversible, then we will call it isentropic also at the same time. So 1, 2 is isentropic compression. Now 2, 3. How will you name this process? Process 2, 3. From that you can name it. Volume is not changing, so we will call it constant volume process. And during this process, heat is added to the system. Suppose this is QS. So process 1, 2 is isentropic compression. Process 2, 3 is constant volume heat addition. Good. Now process 3, 4. From diagram you can say this is also same. I mean expansion, because volume is increasing. So 3, 4 is expansion process, and for this also P V to the power gamma equal to C, and if it is frictionless or reversible, then we will call it isentropic expansion process. Process 3, 4. Now 4, 1 is again, you can see this is, in this case also volume remain constant, and this, in this case the heat is rejected by the system. The cycle rejects the heat during this process. So we will call it constant volume heat rejection process. Okay, fine. Now in actual engine, how it may happen, in that case also we will assume something, and in this diagram you can see this is what volume V2 is equal to V3, and for this is volume V1 is equal to V4. Volume remain constant from 2 to 3, and from 4 to 1 volume remain constant. Now suppose we have a cylinder and piston arrangement. Okay, this is piston and this is the cylinder. What is this? This is cylinder. And this is the piston, P, we name it P. Now at this position, if the piston is at this position, what is the volume inside the cylinder? Upper pressure, what is the volume? That is V2 or V3. Okay, so initially suppose the piston was in this position, that means in the TDC, we will call it BDC. We are familiar with these terms, TDC. So initially the piston was in the BDC position, that means volume V1, and piston moves from BDC to TDC. So what will happen? Definitely the compression will take place, and that is the process 1, 2. The piston moves from position BDC to position TDC, and that is compression process. So if the process is isentropic compression, then definitely we know when we compress a gas, as per gas law we can say what would happen. Gas kinir ki hobo? Kiba ta gas jodi ami compress koru, temperature, pressure, volume ki hobo? কি হ'ব কোৱাচোন? কি ভলিউম ডিক্ৰিজ হ'ব, that is why it is compression process. আৰু pressure increase হ'ব. So from PV diagram you can see pressure increases from P1 to P2. Okay, pressure increases from P1 to P2. আৰু এটা কথা তোমালোকে এইমাত্ৰ ক'লা, টেম্পাৰেচাৰ কি হ'ব? increase হ'ব. So process 1 to 2 আমি কি process বুলি কৈছিলো? Isentropic compression. Isentropic compression, adiabatic compression. গতিকে adiabatic processor condition কি আছিলে? What is called adiabatic process?
Sir, no heat is supplied or is it?
Good, wonderful. So this এইটো এটা piston হয়, cylinder হয়, definitely তাৰ পৰা তো heat ওলাই যাব খুজিব. Definitely যদি temperature increase হৈছে, that means that heat, the cylinder may lose the heat to the atmosphere, lose কৰিব খুজিব. গতিকে আমি assume কৰিছো that at this moment when the process 1 to takes place, this is assumption, the cylinder is kept in an insulated. This insulation, heat cannot enter or heat cannot go out of the system. That is called the thermoflux type thing. So in this case, heat is not going out of the system. So a process to get me isentropic kobo parone, adiabatic kobo paru. If it is insulated cylinder to heat loss na hoy. So in actual engine, we assume that the heat is not interacted with the car logot interaction na hoy, heat interaction atmosphere logot ba surrounding or logot heat interaction na hoy. Now next process is 2-3 process. Kenekwa process? Constant volume process. Hetu keneke hobo etia? Constant volume process hobo lagile aru heat addition process hobo lagile ki hobo? Heat add keneke korim ami? Agor to ami insulation rakhichilu, etia to ami heat add koribo lagibo. So there is another assumption, just a moment moi tumulok dekhaisu keneke hobo pare, assume keneke korise. So suppose we are adding the heat from outside, okay? Keneke add koribo paru? Suppose we have a heat source of heat, infinite heat source. Bahut heat yat ase Q, This is heat. Jodi ami during the process 2-3 a source to cylinder logot logai diu aru if this is good conductor of heat, cylinder head to jodi good conductor of heat hoy, then during this process 2-3 when the volume remain constant, it will receive some amount of heat, say Qs, and we assume that we add heat to the cylinder by bringing a heat source which has an infinite heat capacity, and it can give heat to the supply heat to the cylinder. And for that we assume that the cylinder head is perfect conductor. That means if we bring the heat source in contact with the cylinder head, then it will immediately receive the heat. That is another assumption. Kiba jodi confuse hoise loge loge hudiba, assumptions only, these are. So this way we add heat to the compressed air, already compressed hoisil, now we add heat. Now what next process to ki ase? Next process is process 3-4, and we call it
এটা process sir process ta kobo bujhe dikchu
kontu process 2-3.
acha
2-3 good. So 2-3 process ot ki hoise according to PV diagram ki dekhaisu ami
sir volume constant
ase kintu ami heat add koribo lagibo. So ami heat add keneke koribo? Eta cylinder ase tar heat add koribo lage. আমি জেনারেলি আমি কিবা এটা বস্তু যদি হিট এড কৰিব লাগে কি কৰো? আমি গৰম কৰিবলৈ কিবা এটা বস্তু বাৰ্ন কৰো, বা আমি কৰিব পাৰো এটা গৰম বস্তু যদি তাৰ কন্টেক্টত ৰাখো তেতে সিলিন্ডাৰটো হিট পাব নে নাই?
yes sir
পাব। হেইটোকে আমি ধৰি লৈছো যে আমি এটা গৰম বস্তু ইয়ালৈ আনি পেলাই ইয়াৰ লগত কন্টেক্টত ৰাখিছো আৰু তাৰ পৰা হিট লব, হিট সাপ্লাই হ'ব। আৰু কি এজিউম কৰিছো যে হিট সাপ্লাই হ'বলৈ সিলিন্ডাৰটো যিটো জাগাত আমি কন্টেক্ট ৰাখিছো perfect conductor. That means heater jodi contact ahe, it will not give any obstruction to the flow of heat. Immediately the heat will be absorbed by the gas inside the cylinder. Assumption only, just it really in practice it never happens. Ami assume korisu je cover pura heat ami ani cylinder bhitor khumai disu, gotike keneke hobo pare? Practical থিঙৰ জৰ লগত বস্তুৰ লগত যদি আমি ৰিয়েলিটিৰ লগত যদি মিলাই চাম, আমি ধৰি লৈছো যে এটা বিৰাট বেছি হিট কোয়ান্টিটি থকা বস্তু এটা আনি কন্টেক্টত ৰাখিছো, ৰাখাৰ ফলত হেটো সিলিন্ডাৰটো গৰম হৈছে। জেনাৰেলি আমি হিট কেনেকৈ কৰো? এটা ধৰা তোমাৰ লগত এটা গৰম বস্তু আছে আৰু এটা ঠাণ্ডা বস্তু আছে, তুমি ভাবিছা মই ঠাণ্ডা বস্তুটো গৰম কৰিব লাগে, বাট ইউ ডু নট হেভ এনি ফায়াৰ নাই কিন্তু এটা গৰম বস্তু আছে তোমাৰ গৰম বস্তুটো যদি ঠাণ্ডা বস্তুটোৰ কণ্টেক্টত আনো গতিকে হিট উইল অটোমেটিক্যালি ফ্লো from hot body to the cold body. That is the principle. বুঝি পাইছা?
Isentropic expansion.
Expansion. গতিকে আইসেন্ট্রপিক এক্সপানশন হ'ব লাগিলে কন্ডিশন হিট এক্সচেঞ্জ হ'ব লাগিব যেতিয়াই আমি 2-3 প্ৰসেছত কি কৰিছিলো বুলি কৈছিলো এটা হিট সোর্স আনি দিছো যেতিয়াই এক্সপানশন কৰিম সেই সোর্সটো যোৱাৰ লগে লগে ইমিডিয়েট আমি কি কৰিম আকৌ ইনসুলেটৰটো আনি ইয়াত লগাই দিম সাপোজ এটো জাস্ট ইমাজিনেশন অনলি উই এজিউম দ্যাট এতিয়া আমি এটা ইনসুলেটৰ লগাই থৈ দিছো গতিকে হিটটো কত না যায় ভিতৰটো নহয় বাহিৰটো নহয় যি হিট এড হৈছে ডিউৰিং দ্য প্ৰসেস 2-3 থে হৈছে ইমিডিয়েটলি আমি কি এটা বস্তু আনি দিলো ইনসুলেটৰ আনি পেলাই আকৌ সিলিন্ডাৰটোত লগাই দিলো যিটোৰ কাৰণে হিট আৰু এক্সচেঞ্জ হ'ব নোৱাৰে and therefore the piston will be pushed towards VDC গতিকে যেহেতু এটো বহুত হিট লৈ ললে 2-3 প্ৰসেসত হিট এবজর্ব কৰিলে হিট এবজর্ব যদি কৰে কিবা এটা গেছে তেতিয়া কি হয় আকৌ pressure increase হ'ব excellent good so এই pressure to a piston to ঠেলি দিব and that is called work done ঠেলি কেনেকৈ দিব কিনেকুৱা কন্ডিশনত ঠেলি দিব during that process there is no heat exchange and that is why we call it isentropic or adiabatic expansion আৰু কেনেকৈ হয় প্ৰ্যাকটিক্যালি কেনেকৈ হয় বুলি ভাবিছো আমি এজিউম কেনেকৈ কৰিছো যে ডিউৰিং দ্য প্ৰসেস 3-4 আমি সিলিন্ডাৰটো এটা ইনসুলেটিং মেটেৰিয়েল দি একদম ধুনিয়াকৈ ৰাখিছো আৰু সেইখিনি সময়ত কোনো ধৰণৰ হিট এক্সচেঞ্জ নহয় নাও ইজ ইট ওকে হৈছে
yes sir
নাও নেক্সট কি প্ৰসেস 4-1 to কেনেকুৱা প্ৰসেস heat rejection process আৰু ভলিউম একে থাকিব সো এক্সপানশন হয় সিলিন্ডাৰটো পিস্টনটো কলৈকে আহিলে এতিয়া 3-4 ত সিলিন্ডাৰটো পিস্টনটো কলৈকে গল B দিছিলে so at this position 4 that is called position 4 of this cycle volume remain constant এতিয়া আমি হিট ৰিজেক্ট কৰিব লাগে ভলিউম একে থাকিব হিট ৰিজেক্ট কৰা অলপ আগতে কৈছো হিট এবজর্ব কেনেকৈ কৰিব পাৰো আমি যদি এটা হট বডিৰ সংস্পৰ্শত সিলিন্ডাৰটো লৈ আহো বা হট বডি এটা যদি সিলিন্ডাৰৰ লগত কানেকশনত ৰাখো দেন the cylinder will absorb heat and that will enter into the cylinder এতিয়া আমি কৈছো এতিয়া তো হিট কিছু আছে এই হিটখিনি ৰিজেক্ট কৰিব লাগে to the surrounding কেনেকৈ কৰিম বুলি আমি এজিউম কৰিছো now we are bringing a cold body in contact with the cylinder now this is cold body this is called agoto asil hot body now this time it is cold body so gotike cold body jodi ami eta contactot anu cylinder tot tete cylinder er pura heat humabo ne ulabo ne cylinder ot heat humabo ulabo so that good that is called heat rejection and how heat is rejected at constant volume so therefore the process 4-1 is heat rejection and because of the heat rejection the temperatures comes down to the original temperature prothome jitu temperature ase and that is the point 1 so this way the cycle is completed so this is called air standard cycle or I mean specifically we will call it Otto cycle or constant volume cycle now why the constant volume cycle name to kor pura ahile because heat is added তাৰ পৰাই নামটো আহিছে heat is added at constant কি constant volume because the heat is added during the process 2-3 at constant volume and from that it is given the name constant volume heat addition cycle and this was discovered by one scientist whose short name is Otto, known as Otto cycle and this Otto cycle is actually applicable for all petrol engine heat engine or bitorat all petrol engine key principle use hoy constant volume heat addition principle use hoy so this is how a constant volume cycle or Otto cycle works? Very good. Constant volume heat addition. Okay, that is constant volume heat addition. Next to key process hobo.
Sir, isentropic expansion.
Good. 3-4 is isentropic expansion. Good.
That constant volume or heat rejection.
Good. Constant volume heat rejection. Ebar ki hoise heat rejection hoise. So these four processes constitute what? A cycle, and that we call Otto cycle. Compression, ekdam short kori jodi kau, compression, heat addition, expansion, heat rejection. So key process? One is compression, heat addition, QS, then expansion, and heat rejection, QR. And this expansion process gives work done. This is work done by the system, because expansion means work done. PV, ami paisulu noy PV to change hoy, actually PdV, it changes, so that is equal to work done. Work done. PV means work done. PV ketia hoise? During the expansion process. Agor process to hoise, but during expansion process, some force due to the pressure is pushing the piston from TDC to the BDC. That is called work done. What is the definition of work done? If we apply some force and if there is some displacement, then we call work is done. And mathematically, we call the amount of work done is equal to force multiplied by distance traveled in the direction of the force. So this force is equal to pressure into area. Force equal to what? Force equal to pressure into area. So force multiplied by volume dV, that is we call, not dV, ds, distance travel, then that become pdV, and that is work done. That is as per the law of physics. Physics of that is the thing, and we consider it for a practical aspect. Practically, ki hoy take ami discuss korisu. এতিয়া মোক তোমালোকে কোৱা এই গোটেই সাইকেলটো আমি এনালাইসিস কৰিব লাগে সাইকেলটো এনালাইসিস কৰিম এই সাইকেলটোত হিট এডিশন কিমান হ'ব বাৰু কোৱাচোন গোটেই সাইকেলটোত হিট সাপ্লাইড কিমান হ'ব কেতিয়া হ'ব volume constant process is 2-3 so during process 2-3 heat is supplied means it is heat transfer heat interaction. So during constant volume process, you try to recall what is the amount of heat transfer during a constant volume process. 1, 2 during a constant volume equal to mCV T2 minus T1. This is so easy. Constant volume process. Hi. Abane moi ekbari na kiba confusion ase. So QS equal to mCV. Why CV? Specific heat at constant volume, because the process is constant volume process. M is the mass of the air. Jiman kini air bhitorot ase hekini mass. And what is the temperature difference? Temperature difference T3 minus T2. So a process 1 2 thakile T2 minus T1 hoy. Kintu amar process tor naam etia 2 3. So it will be T3 minus T2 QS. That is the amount of heat supplied. Whole cycle or bhitorot heat supply ekhiniya kintu. Sarita process ase. Sarita process ot beleg dhoronor event hoise. Beleg type or process. But heat supply boli jodi kau, heat supply takes place only during the process 2-3. Aru heater interaction kiba process ot hoise neki? Konba eta process ot heat interaction hoise neki aru beleg process ot? Koasun? Good, very good. So heat, that we call the heat rejected during the cycle, okay? Heat rejected. Ketia hoise? During the process 4-1 not hoise. আৰু এটো কেতিয়া হৈছিল during the process 2-3 so what is heat rejected QR বুলি আমি কম আৰু আমি ইভেন এনেকে লিখিব পাৰো Q41 processত আৰু এটোত লিখিব পাৰো Q23 now QR equal to কি লিখিম process to কেনেকুৱা process 41 to constant volume process that is also constant volume process good now that is for same formula constant volume m cv temperature higher temperature minus lower temperature now what is higher temperature definitely T4 good T4 minus T1 so this is heat rejection during the cycle heat interaction দুটা process hoise eta 2-3 eta 4-1 but 2-3 is heat addition and 4-1 is heat rejection and what is the heat engine ami heat engine pai ahisilu monot ase na heat engine is a device which takes qs amount of heat and reject qr amount of heat to the surrounding or sink and we get the work output w net equal to qs minus qr monot pore second law of thermodynamics and that is called heat engine so this is heat engine only we are calling it a specific cycle that is Otto cycle now w net equal to how much work done during the cycle equal to kiman hobo according to the second law of thermodynamics heat supplied minus heat rejected so jeti hetu ami gom palu now we can find out the efficiency of Otto cycle jehetu etu Otto cycle tar naam ami eta Otto বুলি কম that means efficiency of Otto cycle or air standard efficiency of Otto cycle is equal to kiman hobo work output w net divided by heat supplied qs so that is the formula initial formula for Otto cycle now we know what is qs kiman w net equal to qs minus qr so it will be divided by qs and that may be equal to 1 minus q r divided by qs okay eteleke thik ase now ami yak aru olop agbadhai loi jam keneke loi jam process 1 2 3 4 asile efficiency kiman palu ami koasun efficiency ki palu eteleke
1 minus qr divided by qs
very good Otto cycle or efficiency ami palu 1 minus qr divided by qs alop agote ami qr aru qs uliaisu what is qr m cv t4 minus t1 divided by m cv t3 minus t2 so m aru cv cancel hobo and it will be T4 minus T1 divided by T3 minus T2 efficiency in terms of temperature now yak ami alop simplify korim aru 1 minus ধৰিলো ওপৰত আমি T1 কমন লৈছো T1 কমন ললে কি হ'ব থাকিব কি T4 divided by T1 minus 1 আৰু তলত কি কমন লম T2 কমন লৈছো and what will remain T3 divided by T2 minus 1 yak ami alop simplify loi jam now etia aru eta bostu lage ami last few days of we got the isentropic law adiabatic law and gas law and from that the process 1 2 what is this process key process isentropic compression hoy now it is isentropic process so for isentropic process T2 by T1 is equal to monot pore ne karobar V1 by V2 whole to the power gamma minus 1
yes sir
good so V1 by V2 to the power gamma minus 1 now ekhinite aru eta bostu ahile V1 what is V1 this is V1 what is V2 this is V2 now during the compression process V1 by V2 etu kami ki naam dim V1 by V2 ki naam asile konobai kobo parile
RT
wonderful good excellent so this is called RC what is RC compression process is compression so this is compression ratio RC বুলি কৈছো so we can write RC to the power gamma minus 1 fine 3-4 process 3-4 to key process eto isentropic process tate jodi ami isentropic law apply koro what will get T3 divided by T4 is equal to V4 divided by V3 whole to the power gamma minus 1 now diagram what is V4 V4 equal to V1 this is V4 and what is V3 V2 equal to V3 from PV diagram you can see and that is equal to V1 by V2 whole to the power gamma minus 1 now a bar V1 by V4 by V3 to ki boli koi baro what is V4 by V3 we call it RE that is expansion ratio because the process is expansion but RE is equal to RC so ultimately we can write RC to the power gamma minus 1 etia tumi soa this is equation 1 and this is equation 2 left side is different right side is same right now good okay so we can say left side will be equal so what is left side T2 minus divided by T1 equal to T3 divided by T4 eto asel sage T yes T3 divided by T4 aru TT kiman 1 2 3 4 now etuk jodi ami akko rearrange koro so what we will get T4 divided by T1 is equal to T3 divided by T2 hoy na baru etur pore paiso ami
yes sir
good olopokote ami equation to ki paisulu efficiency of Otto cycle is equal to 1 minus uporot ami paisilu T1 common loi T4 divided by T1 minus 1 tolot paisilu T2 aru T3 divided by T2 minus 1 etia ei bostu khini mon korisane eke je hoy etu aru etu hol etu so ei duta term jodi eke hoy ei gute khini nai ki hoy jabo thakibo ki 1 minus T1 divided by T2 or you can say 1 minus 1 divided by T2 divided by T1 or you can say 1 minus T2 divided by T1 given as RC to the power gamma minus 1 so this is the efficiency of Otto cycle na? Finally we derive one relation for efficiency of Otto cycle what is that keep alu 1 minus RC to the power gamma good so today we deduce one relation of Otto cycle ki hoy efficiency of Otto cycle equal to 1 minus 1 divided by RC to the power gamma minus 1 so this relation is very important from in this semester as well as in the coming semesters you to know the efficiency of Otto cycle okay now you tell me yat kiba question ase niki eta lage so simple relation eta palo jodi amak compression ratio dia thake we can find out the efficiency of the Otto cycle only thing we have to know the compression ratio ete kwa compression ratio RC jodi increase koro ami tete efficiency ki hobo bol kosun baribo good from relation you can know because this is 1 this is constant minus 1 by RC to the power gamma if we increase RC then 1 by RC to the power gamma minus 1 will decrease so we can say efficiency will increase so Otto cycle efficiency increase koribole ami ki koribo lagibo we have to increase the compression ratio now what is RC RC equal to V1 by V2 আৰু সৰি v1 by v2 নাও v1 মনত পৰে নে তোমাৰ লগত what is v1 এটো ডায়াগ্ৰামত যদি চোৱা this is v1 and this is v2 but this volume we call vc মনত পৰিছে this call vs তাৰমানে এই ভলিউম যিখিনি ৰৈ যায় this is called clearance volume মনত আছে আৰু ইয়াৰ পৰা যিখিনি ভলিউম থাকি যায় vs that is called swept volume